Let's continue with another example. Estimating limits graphically. Use the graph of the function f in the figure to find the following values, if possible. All right. If it's not possible, try to give a reason of why it's not possible. So let's practice rewriting these expressions. Whenever you rewrite expressions, make sure you copy the original expression down. For this example, I'm probably going to write top to bottom. So let's look at f of -1. F of the value, the input value is -1. So -1 is down here. Where is the function value? What is the output value? The output is actually +1. And we're done. I did say we'll write top to bottom. So if I write this top to bottom, it would just look like this. So either way, all right, but I'm going to write top to bottom. Remember the double bar symbol means is to have the same value as. All right, treat this double bar symbol as is to have the same value as. So a lot of times when we rewrite expressions, we'll use this double bar symbol. The next expression involves a limit. It's the limit as x approaches -1 from the left-hand side. Where do the corresponding f of x values go? So a tip in reading limits is always read the domain first. You know, as x approaches -1 from the left-hand side, where do the corresponding output values go? Okay, so let's look at that. Let's look at that. As x approaches -1 from the left-hand side, as x approaches -1 from the left-hand side, where do the corresponding function values go? They're actually approaching the number called 3. So I'm going to write that. They're approaching a number called 3. Yeah, I'll circle that. How about the next part? The next expression is the limit as x approaches -1 from the right-hand side. Where do the corresponding function values go? Let's see. As x approaches -1 from the right-hand side, where do the corresponding function values go? They're approaching a number called +1. So we'll write that. That is to have the same value as +1. Make sure you rewrite the expression. I'm looking for limit notation. Make sure you're able to write the limit notation and the subscript of x's. Okay, remember x arrow a is a subscript. X arrow a is usually a subscript. Part D. Let's write the limit as x approaches 1 from both sides. I'm sorry, as x approaches -1 from both sides, where do the corresponding function values go? Well, the issue is that 3 is not equal to 1. So the limit as x approaches -1 from both sides does not exist. Notice the corresponding function values do not match, or they do not approach the same number. You know, 3 is not equal to 1. So this one here, we simply are going to write the expression or the phrase DNE. And what does DNE stand for? DNE means does not exist. Okay, so if it doesn't approach the same finite number, then we say that the limit of that function does not exist, or the limit as x approaches a from both sides of that function does not exist. All right, next example. What is f of 1? What is the expression f of 1? F of 1, we know that output is 5. And we're done. So f of 1 is to have the same value as 5. Next example involves a limit notation. So practice writing your limit notation. The limit, as x approaches 1 from both sides, where do the corresponding f of x values go? So practice reading the domain first, and then go ahead and try to read the corresponding outputs. Looks like they're going to 5. And that's what we're going to write. Next example is another expression involving limits. So write lim, write the subscript as x approaches 2, and then we have f of x. So as x approaches 2 from both sides, where do the corresponding output values go? Corresponding output values are going to 4. Next example, once again, is another expression. Let's look at the expression. The limit as x approaches 3 from the left. Where do the corresponding f of x values go? As x approaches 3 from the left, where do the corresponding f of x values go? They're also going to 3. There we go. One more here. Look at the limit as x approaches 3 from the right. Where do the corresponding function values go? They're going to 5. I'm going to write 5j right here. 5j is the limit of f of x as x approaches 3 from both sides. Where do the corresponding function values go? So in this case, if you approach 3 from the left, it's going to 3. But if you approach 3 from the right, the corresponding y values are going to 5. So 3 doesn't equal 5. So what we're going to write now is does not exist. So that limit as x approaches 3 from both sides does not exist. And that will conclude our writing for this example.